Kelvin's final project. So, turn it on. It says Weather Dominator, author Sawyer Kelty. And then CSE412, Group 11, final project. Capable of taking room temperature in Fahrenheit, Celsius, Kelvin, and Rankine. And additionally capable of controlling 2 fans. Then the instructions. Button 1 alternates between temperature scales. And that's button 1 right there on the Atmega. Then button 2 controls fan 1. Button 3 controls fan 2. Those buttons are back here. Those little tiny push buttons. And those are the 2 fans. Now, it's already displaying the room temperature in Fahrenheit by default, where it's 73 degrees, 0.46 or 73.46 degrees Fahrenheit. And then both fans are off, so it's displaying 0 volts from that readings. And then line 4 has a menu. Button 1, FCKRA, means that it's going to start with Fahrenheit, and then if you press it again, it's going to go to Celsius, and then to Kelvin, then to Rankine, and then it's going to display all temperatures. Then button 2, F1, is fan 1 button control, and then button 3, fan 2 control. So if we press this button back here, it's on a 2.5 second delay. It should turn on. Let me press it. All right. Oh, it's unplugged. Okay. There we go. Then, so that turns fan 1 on. Then we're going to turn on fan 2. So there are both fans on right now. And then we started this at 70 degrees, but those fans are blowing directly on that thermistor back there, and that is causing it to cool down. And so there's 2 potentiometers back here. So if you pay attention to the voltage reading right now, they're 1 and 1. If I can increase the resistance of these potentiometers that they're connected to all the way down to where it turns them off, or at 0.6 where it's just like slowly going, or all the way off as I've done on the left. Now I can increase it and then go all the way back up, and right there it's displaying 1 volt again. And I can do the same thing for the left fan and stop it, or I can increase it. And so that gives you a wider range of volts and speeds to control the fans that the user is able to do. Now I'm going to go ahead and turn off the fans. So there's that one off. Now just to show you that it's going to work even on Celsius, Celsius is still displaying the fan 1, and Celsius degrees is in 21.47. And so you can turn these fans on and off at any point in the program. And so now if I press this button over here again, we go to Kelvin, which is 296 degrees. I press it again. We go to Rankine, which is 534 degrees. I press it again. We go to our all menu, which displays the Fahrenheit, Kelvin, Celsius, and Rankine. And it's on a 2.5 second delay, which is why it keeps refreshing the screen. And so, Fahrenheit 74.5 degrees, Kelvin 296, Celsius 25, or 23.56, and then Rankine 534. So those are all your values at once. And then if I wanted to, I could turn the fans on again by pressing that back button, but you just can't see this voltage. But if I were to go back to Fahrenheit, which is what it will go to since it's in that order, you can see it's getting 1 volt. Now, let me turn this off. I turned it on. All right. And both fans are now off. Now to show you the program that is controlling all this. All right, we go to atmel. This is the main.c file for it. There's the notes about the project, but if you go down, you can see that we have this p choice variable, which we're going to set to 6, our fan 1 check, which is 0, our fan 2 check, which is 0, and that's going to be important for later. This enables you to have a timer delay. These are for the mathematical operations, decimal or D to F, string F conversion, AVR/IO. Those are all just libraries we're including for necessary things. And then if you scroll down, this is our void LCD, which is going to write 38 to the LCD. And what that does is it sets 8 data bits and for a 2-line display to let the LCD know that there's multiple lines of like that's going to be writing to where it's going to not just display only 1 line, but it's going to use all 4 in this case. And then we have our analog to digital conversion get right here, which is going to fetch that data from pin 0, which is connected to the thermistor, which enables right here. These are all just variable declarations in order to store the data and then recall it. And so here's our ACC, and now we're able to use the thermistor equations to adapt the thermistor to analog to digital conversion. And by doing that, we're able to get the temperature in Kelvin, and then we convert that temperature to Celsius, and that temperature to Fahrenheit, and then that temperature to Rankine. And then we're going to store all those values as strings. And then now if we go to our switch p choice, which is the first thing that will come up when this function is ran, it will go to 6 because that was the default setting, which means the user choice is equal to 1. Now, if we're going to run through this the second time, whenever the user choice is equal to 1, it's going to be checking that pin B7, which is the push button on the atmega. And if that button is pressed, then the user choice is going to be set equal to 2. Otherwise, the user choice is going to remain equal to 1, and it's going to continue. You can then, if it is 2, it'll go down to case 2, where then it's going to change to 3, and so on and so forth for each of the different cases. And then we have a fan 1 status switch, which is going to start off at 0, which is the fan is initially off. It's going to set the direction of pin C5 to an output, and then it's going to read pin B4, which is connected to that button for fan 1. And if that's pressed, it's going to set the fan 1 check to high, which means it's just kind of for this switch storage or switch. It's instrumental in having the switch work. And then it's going to have a port C and equal that little tilde 1 less than port C5, which is going to set port C to high, and it's going to output the voltage, making the fan turn on. And then if the fan's initially on, this is case 1, when you press it, it's going to turn the fan off. And this is the same similar setup for fan 2, except instead of pin C5 we're using pin C4. And then additionally, instead of pin button 4, we're using pin button 3. And now if we go down to this is where the user choice came into play from earlier, if you recall. We had this user choice default equal 1 or it'll equal 2, depending on what button is pressed, but it'll always be in this order of Fahrenheit, Celsius, Kelvin, Rankine, and then all. And so if we go down to here, it's going to start off by setting the cursor to home, and it's going to clear the display. And then it's going to display the Fahrenheit, the temperature as a string, and then it's going to use ADCP2, which is a function in this assembler. And what this does is it's going to load 0x42 to register 16, which is then stored in the addmux. And what that is useful for is setting pin C2 to input by loading 0B00000100 binary, I believe, because it's only going to set pin 2, or it's 10, yeah. And then for this one, it's a similar story, except it's all going to be, it's like B0000, and that's going to set pin C0 to input. And then this one only sets that last, or the first initial bit 0 number to 1, which is going to make pin C1 an input. And so what that does, though, is that enables us for whenever we use our get voltage function to read that analog or make that analog to digital conversion and store it as a voltage, which is then going to be displayed. And so then we set it for pin C1, which is connected to our fan 1. It's going to read that voltage and then display it, and then it's going to lastly put a menu, and it's going to have a 2.5 second delay in order to have the screen not just flicker, and it's going to let the user be able to read it and see what all is happening. And so then our analog to digital conversion, we're just resetting that back to 0, how we found it for the next temperature conversion. And then we set the previous choice equal to 1 to catalog that, this is our default setting, sort of. And then, this was what's last input, to where it's going to constantly go back to displaying Fahrenheit until the button's pressed. And so that's pretty much how cases 2, 3, and 4 also work. But with case 5, it just displays Fahrenheit, Celsius, Kelvin, and Rankine, rather than also displaying the voltages. And then this is a get volt function, which does the analog to digital conversions to store that analog data as voltage. And then we have our void boot display, which is what is displayed at the beginning, and so it initializes this LCD, and then it's going to display the final project, group 11, the instructions for how the Weather Dominator works, and that is what that does. And so in our main void, it's going to start off by having Mega 328PB initialized, and then it's going to run the boot display, and then it's going to endlessly do the LCD loop. And that summarizes Group 11's final project. Thank you for watching.